Let's put a title on this notebook page. We're going to be doing lesson 1.5, and we'll call them notes 3 because this is our third set in this lesson, okay? And we're going to have the same learning goal as we had yesterday. We're going to still be solving equations in one variable with variable terms on both sides. But first we're going to look to see what kind of simplifying we can do before we do the solving. So let's put that note to ourselves. We are going to simplify first. Simplify first. Look to make sure that see if there's any simplifying that can be done on one side or the other side. Maybe both sides are going to need their own kind of simplifying. And then solve. Okay, we're not going to start solving it until we've taken the time to simplify it. These get fairly tricky. So how many of you found success with the ones that we had to simplify yesterday? What those were for you? Anybody remember? Hey, give me a let's do a fist to 5 on a 1 to 5 scale. 5 feeling like, you know what, I really got that figured out yesterday. I can simplify it well. And a 1 being, I'm still lost. And then somewhere in between, you decide what's your comfort level with these 1 to 5. Okay, everybody put up a 1, 2, 3, or a 5. So a whole hand, or a see what your comfort level is. 1, 2, 3, 4, or 5. Okay. So we're, looking like we have for those of us that were definitely here, we're feeling fairly comfortable with it. Okay, good. Thank you. So yesterday, the simplifying that we had to do, does anybody remember which simplifying step was the only one we actually used yesterday before we were ready to solve? What was that simplifying step that we used yesterday?
You would take if it had 2, for number 1 yesterday we did 10 amps and 2 amps. You would make those two, since they're on both sides, you would put them together.
Okay, since they were on the same side, right? Yeah. They were actually on the same side, and when they're on the same side, and we can call them like terms, we can combine them, we can put them together, right? So the simplifying step we used yesterday was the combining like terms one. What's our other simplifying step that we also used but did not have to use yesterday? Andrea remembers this one, distributive property. So today we're going to have to do some of that also. So we're going to do some distributive property and or some combining like terms. So let's put that we're going to do some practice. We're just going to go straight to practicing again. And that's a C. It's a funny C, but it's a C. And number 1, I want you to write down this problem just as I put it up here on the board, okay? So I'll just write it instead of saying it, and then you can just look up to copy it. So make sure you copy it down carefully, first of all. So we're all working with the same equation. Okay, so remember, even before we start simplifying, what's the first thing we're always going to look to see if the equation has? Any subtraction, yes, if it has any subtraction going on in it. Because if it does, we're going to change that subtraction to add the opposite, aren't we? So, do we have any subtraction? Yeah, we do. So we're going to rewrite the problem. Don't do it in the problem itself right now. Let's see how this one started. Don't mess with it. Like my red line, yours is just a pencil, of course.
M plus -6.
Let's just write on another line. Let's just write, what's its new name? We're just renaming it is all we're doing right here. We're not simplifying it, just renaming it. Okay, now we're ready to start simplifying, right? Do we have some combining like terms to do, or what does it look like we have to do? Seth? We have some multiplying to do. We have that distributive property to do, don't we? So we have to take this 2 times the m and times the -6, don't we? And bring our plus sign down in between them. So are we ready to not write the multiplications out, or think we still should? How many of you, right now, what would you write down in the next step? What would you write on the next step? Go ahead and do it on your papers, and let me see what your next step would look like here. What would you multiply this? How would it turn out? Did you really do it?
What?
Did you use this one?
I get
Well,
that
that's 2 steps.
Yeah. Yeah, that's the next step. Okay, because what we were doing before, and the reason I wanted to see what you did is, remember what we were doing before when we did distributive property, we were showing the multiplications like this, weren't we? 2 times m plus 2 times negative 6. That's how we were showing our multiplying, weren't we? 4 times m on the other side, and plus 4 times 4 on the other side. I think we still need to probably show that step. I don't know if we're ready to jump past that step. Anybody feeling confident that they are, and they're want to stake claim to not having to do it? Okay, then we're just going to all do it. Okay, what's the result of our multiplications? What do we get for our first multiplication? 2m.
Plus negative
Our second multiplication gives us a negative 12.
12.
Our first multiplication on the other side is 4m and plus 16. Okay. What do you think? Do you think we have any other simplifying we could do on the left side? What about this side, the left side? 2m plus negative 12. Are they like terms? No, they aren't both m's, nor are both of them constants. How about the right side? Do we have any like terms on the right side? No, those aren't like terms. So what can we say to ourselves? We are ready to solve it. We're ready to solve. We're ready to go about solving it. Now let's draw our line showing that we're actually solving now. Because once we start solving, we do the same thing on both sides, right? Okay. Who wants to suggest a good first move for this one? Blake?
Minus 2.
Okay, subtract 2m from both sides. Both sides have a variable term. Both sides have a constant term. So since they both have each of those things, let's get rid of a variable term first. And Blake is going to suggest that we get the 2m out of here. So that's a first move we could make. After we make that move, we now have, these cancel out, right? We have negative 12 left. What do we have on the right side?
2m plus 16.
2m plus 16. Because 4 m's take away 2 m's, leaves us 2 m's. And then our plus 16. Okay, and then what's our next move, Adam?
Subtract 16.
Subtract 16 from both sides.
Cross out by 16 on.
Okay, these guys cancel each other out.
Yep.
Okay, over here, what do you think we should do on this left side with this negative 12 minus 16? This is a subtraction here. What do you think I'm going to suggest we do? Change it to add. And what's the opposite of 16? Negative 16. So we have a negative 12 plus a negative 16. Negative 28. They're both going in the negative direction. So we add their distances together, 12 and 16. And we get 28. And we say they're going in the negative direction, so that has to be a negative distance now. And then we have our 2m left on the other side, right? Okay, one last move left, right? What is it? Divide both sides by 2, yeah. Okay, so we're going to take negative 28 and divide it by 2. We're going to take 2m and divide it by 2.
You cross out the 2 line.
These 2's cancel. Are those ones you want me to cancel out?
That's going to be
Negative 24,
-24.
huh?
No,
Okay.
negative 14.
Okay, yeah. A negative divided by a positive is a
Negative.
negative, and there's 14 2's in 28. So there's our solution. Okay, I'm going to guess that you're doing a book assignment again today. I'm going to guess that in the book it's going to tell you not only to solve these, but to check them. I'm going to let you off the hook for checking them, anybody tells you to check them, you do not have to do that. We're gonna just focus, spend all our energy on solving them. Anybody have any questions on this one?
No.
Anybody work ahead and go about it a different way than we did? Seth, did you? Okay, what was your first one?
I had 12.
You added 12 to both sides first. You like to work with those constants first, don't you? Okay. Did you get the same solution we did?
Yeah.
Okay. Anybody else? Work ahead, and you're like, I didn't make the same first move you did, I went about it differently. Okay, then let's do another problem. You know how much room that one took, so you decide if you have enough room to start the next problem on this same side, okay? Number 2, we're gonna do 3 together, and then you can get to work on your homework. So just copy it down as I have it. We're not going to change its name in this line. We're going to leave it just like it is in this line. Lots of 4s and 2s in this problem. Make sure you get all these 4s and 2s in the right place. Okay, our question is, are there any subtractions? Are there any? How many? 2, yeah. We have to know which ones mean subtraction and which ones mean negative, right? So, is this a subtraction here at the beginning? No, this is a -4, isn't it? This is a subtraction, and these, in each of the sets of parentheses is where we have our subtraction. So we're going to change the name of this only. That's all we're doing in this step. We're going to rename it, getting rid of our subtraction. Because if we don't do this today, trust me, those of you who think you're like, it just doesn't work for me to do that. Well, I don't think it's going to work not to. So please, just, I think to help yourself out, just give in and do it. Okay, after we have it renamed, now we have to decide, is there any simplifying we can do? Is there any simplifying we can do?
You can combine the y.
Can we, these y's are on the same side, sorry, is that what you're looking at, Adam? Can we combine them?
No.
Can we combine those y's? What do you think? Can this y that's sitting in here be combined with that y and become a 3y? No. It's tied to this multiplication problem right now. We can't mess with it while it's in this multiplication problem. We have to take care of it later. Right now, we're going to simplify this, and that's our tag along that's going to come along. And then over on this side, what do we have? We have some multiplying to do also, don't we? Okay, so let's go ahead and get our multiplying shown. -4 times y, so we're going to do our distributive property.
Do we still?
Yeah, we're going to do this. We're going to show this.
No, I was asking if you still have it to box.
Box it, yeah, I was just lagging behind there. We're going to take -4 outside times the -4 inside. And then we're going to take the 2 times each of those. Does that 2 get extended and does an arm go over here and get multiplied by this 2y over here? No, what do we call that 2y again? That's our tag along. It's just going to come along with us. So we're only going to multiply what's the pieces inside the parentheses. So we have those 2 multiplications to do. And then we're going to bring down our tag along because it's still part of the problem. Okay? Okay, go ahead and do all of the multiplications, get your next line, and then we will decide what we can do from there, okay? After you're done doing your multiplications, will you check me out to see if I did them right, please? now then that my multiplication is right?
Yeah.
We can move on. Okay, you guys agree with me, all of us? We wanna make sure we all have the same thing. So now we are ready to say, well, I got the distributive property done, can I do any combining of like terms? Well, can we on the left side? No, there are no like terms on the left side, but I'm hearing Adam say there are on the right side, aren't there? We can circle those guys. They're like terms, they can be brought together. So we're gonna bring down our left side, it doesn't change. Our left side's gonna stay what it is. And then we're gonna say, what is 2y plus another 2y? 4y. So we're not solving yet. All this we're doing, all this stuff we're doing is just getting it ready to solve. What about that negative 8 in the middle? What's it called? Tag along, that has to come along, doesn't it? It has to come along. Okay.
And then when you subtract the negative,
Okay. Now we decide if we are ready to solve. Are we ready to solve? Okay, we're there. Okay. So we're ready to solve. So now we got, we have some options, don't we? Now we look at it and we say there's a variable and a constant, so it doesn't matter. But I would suggest we do the variable terms first. I just think that works better, but some of us prefer to do it another way. So should we get rid of these guys or those guys?
the negative 4.
Oh, the negative 4y? Okay, what would we have to do?
You would add 4y.
Yeah, we do the opposite of negative 4y, which is plus 4y.
16 equals 8y.
So now we bring down, these guys cancel each other out, and we bring down our 16, and what do we have? 4y plus another 4y? 8y plus our negative 8. Okay. Now, would it make sense right now, and this is what some of us do, would it make sense right now to get that 16 moved? Why not? Why should we not even focus on that 16 right now? Because there's nothing else on that side. What is it that we're trying to get alone?
The 8y.
The y's, yeah. It's the 8y that we want to get alone so that eventually it can become just a y. So we look over here and say that we got that negative 8. So what should we do?
You would add the opposites.
We add the opposite, so we're going to add
And the
8 to both sides, yeah.
24 equals 8y.
Okay, so 16 plus 8 you're saying is 24?
Yeah.
Okay,
Equals 8y.
these guys cancel out and we have 8y.
And you divide both sides with 8y.
By 8y? We divide both sides by 8?
By 8.
Just by 8, yeah. Be careful, don't divide by the y. We divide by what y is being multiplied by. Y is being multiplied by the 8, so we divide by the 8. And then we have to do it to the other side also. And what do we get?
3.
3. So these guys cancel, and we say y equals 3. Or 3 equals y, same thing, right? Doesn't matter which side the variable ends up on. Okay. These take a few steps, don't they? We have a few steps of simplifying before we can even do our steps of solving. So anybody have any questions on this one? So I'm kind of just trying to practice a variety of the things that you will see in the homework so that you have good guides to go by. We'll do one more together, and then I think we'll be ready to start on some homework using these that we're practicing together to guide us. Okay. So anybody have questions or not done? Or we move to the last one. Okay. Then let's do this last one, number 3. Write it down first of all. Carefully write that down. Same thing when you're doing these problems in the homework that are from the book. Set yourself up for success right away by copying the problem down correctly. Okay, let's do some renaming here so that we can make it easier to work with. How many subtractions do we have going on in this one?
3.
3 of them. This time we got 3 subtractions going on. We have a subtraction right here. We have a subtraction here, and we have another subtraction here. We got them all over the place. So 3x is going to stay 3x. It is saying subtract 3 times something. It's the 3 that we changed to its opposite. So this is going to become plus a negative 3 right there. And then we're going to put our parenthesis. 2 plus, what number can slip into to right here? In front of that x?
1.
A 1. So we really have a subtract a 1x right now. What's the opposite of 1?
Negative 1.
Negative 1. So we're going to make that a negative 1x. And then over on the other side, 5. It's going to stay 5. The 3x is going to stay 3x. And then we're going to... Somebody blowing or something? And then we're going to change it to plus. The opposite of 3 is?
Negative 3.
Negative 3. Okay. We want to make sure we take a lot of time in this step to make sure we rename it really well and set ourselves up for having a problem that's easier to work with. Okay? Now we look at it and we say, I see some parentheses in it, so I know I have to do what first of all?
Times.
Yeah, timesing. What's that property called? Distributive property. Okay. There's 3 x's at the front. What are we going to do with it?
You just let it come along.
Just let it come along. Yeah, here's a tag along. Let it come along. Bring down our plus sign. And then now we're going to take this negative 3 times both of those pieces, aren't we? So negative 3 times 2. Bring down the plus sign in between the terms in the parentheses. Negative 3 times a negative 1x. That's just the left side. Should we set it up clearly and properly before we move on? Make sure you and I can read your writing. What are we going to do on the right side?
5 times 3x
5 times 3x.
plus 5 times negative 3.
Do we have any tag-alongs on that side? Samuel, do we have any tag-alongs on the right side? No. We don't, do we? Okay, do your multiplications. Let's see if we all agree after just doing the multiplications and bringing any tag-alongs along that need to be brought along. And then check me out when you're done. See if I'm right. I make mistakes. I was making them all over the place yesterday. See if we agree. Or if you wonder why I got what I did, ask me why. Do we need to talk about any of it?
No.
Do we agree?
Yeah.
Yeah? Okay. Then we're ready to solve? Or do we have some more simplifying to
You
do?
can simplify the 3x. You can combine it with other 3x.
Okay, so
Leave
we
three
have
exactly.
these x's on the same side, right? So since they're on the same side, we don't subtract 3x from
It'd be 6
both of
times.
them.
It'd be 6
We-
times.
Just bring them together and say together they become 6x.
Plus negatives.
Plus our negative 6, the tag along in the middle.
And then go.
And then is there anything that can be combined on the other side? No. Okay. And then, how do you feel? Do you feel like we're ready to solve now? Or do we have some simplifying to do yet? Ready to solve? Okay. Let's get our line drawn showing that now we're going to be solving, doing the same thing on both sides. The same exact thing on both sides. Okay.
So add the negative 6.
Add the negative 6.
Well, actually, no, mine.
There already is a negative 6.
I'll let you play.
I subtracted -6.
No, that would, we're not gonna.
Negative, I subtracted the 6x, I meant to say.
Oh, you subtracted 6x.
Yes.
Oh, okay. Anybody else like that move? Like subtracting 6x? Tell me what are some of the other moves we make, because I see some of my people working, so I already know they're doing
You can add
something
6.
else.
You can add 6 to the -15.
Yeah, you can add 6 to both sides, you can move that first. What's another thing you do, Seth? Oh, you could add 15 to both sides to get that out of there. And what's one last choice of things we really could start this?
Subtract 15.
We can move these guys by subtracting 15x. Okay,
I subtracted 6x.
I'm gonna make the move I would make.
That's what
This would be the move I would make. Now, you've already worked ahead and you're doing it, you made a different first move, and just keep working and we hopefully will have the same answer in the end. Okay? So, go ahead and finish solving this one and see what happens. Okay, when you're done, look up and see if you agree with me. If we don't agree, then we gotta figure out where we are going wrong. How do you feel? I think x equals 1? Okay. What if I said to you that I'm gonna give you one more to work on your own, and you're gonna get 20 points of extra credit if you can do it correctly yourself?
I do it.
You do it? You feel confident you can do this? Okay, now, how could you, you're like, I really want to make sure I get the 20 points of extra credit. By the way, you get no help, okay? You want to make sure that you get the extra credit. What could you do to make sure that you had a good answer, other than going back and just looking at all your work and saying, did I do all my stuff I was supposed to do, and blah, blah, blah. What else could you do? Because 20 points of extra credit, that's a lot, isn't it? What could you do? Like, in this one, we think x is equal to 1. How could we be certain? Check it, yeah. We could go right here and we could say, if I put a 1 in for this x, here, and here, and here, okay, what's 3 times 1? 3, okay, and then minus, and then we're just gonna leave the problem like it is right now, okay? 2 minus 1, what is that? 1, so 2 minus 1 becomes 1, equals, I should have used a different color here, 5, and then in parentheses, what's 3 times 1 right here? 3, and, oh, I gotta switch. This is not working for me. And then 3 minus 3, okay. Well now, we're gonna go, we got this multiplication to do, and we got this subtraction to do, so I'm gonna move up here. Right, I'm all over the place, I realize right now, but just follow me, let's just see if we're right. So, what is 3 times 1 right here? 3. So we now have 3 minus 3 on the left side, and we have 5 times whatever 3 minus 0, or 3 minus 3 is in those parentheses. What is that? What's 3 minus 3? 0. Okay. Now, let's keep going. What's 3 minus 3? 0. What's 5 times 0? 0. Do we have a good answer? It appears that we do, don't we? Okay. So you could check these if you really were wanting to make sure that you earned the points that you want to earn for them. Okay. So let's go back to the problem itself. Anybody have any parts of it that they want to talk about? Okay, you guys got this. You're feeling confident? That's awesome.